Diagnosis of an air conditioning complaint starts with a performance test to verify the complaint. Warm the engine to operating temperature and run the engine at about 2,000 RPM with the windows closed and the air conditioning set to maximum cold. Use an air conditioning thermometer in the air outlet to measure outlet temperature. Depending on humidity and outside temperature, the outlet temperature should be between 35 and 45 degrees. Consult the diagnostic charts for temperature and humidity because outlet temperature can be as high as 53 degrees and still be acceptable. If the outlet temperature is high, turn the air conditioning switch off and then on and listen for the sound of the compressor engaging. If the compressor does not engage, further diagnosis of the compressor protection circuit is warranted. If the compressor engages and the outlet temperature is still high, the refrigerant system requires further diagnosis. If the vehicle is equipped with an electric condenser fan, listen also for the condenser fan turning on when the AC is turned on. An inoperative condenser fan will cause poor cooling in the condenser. Next, move the temperature control to full hot and then back again to full cold. The system should respond accordingly. If there is no change or the change is minimal, check the linkage, doors, and vacuum or electrical controls to determine where the problem exists. Move the mode position switch through all of the positions and check for a change in the air distribution. Again, if there is no change or the airflow is diminished, check the linkages, doors, and electrical or vacuum systems to determine the cause of the problem. Air that comes out of the defroster only has a problem with the vacuum supply to the air distribution system. Automatic air conditioning systems usually have a self-diagnostic routine that will store codes in the event of an air distribution control circuit failure. The manufacturer service manual should be used to retrieve and diagnose the stored codes. Engage the recirculation or max mode and listen for a change in blower motor operation and for increased airflow. The electrical circuits will have to be checked if there is no change. Then put the air conditioning system in the normal mode and change the blower motor speeds through all positions. Blower motors that work on high speed only will likely have a failed resistor block. The general diagnosis should conclude with a check for unusual odors. A sweet smell indicates a coolant leak from the heater core, while a strong musty odor indicates a clogged evaporator drain or a bacterial coating on the evaporator fins. A touch and feel test is a quick and easy diagnostic test to determine possible problems in the refrigerant loop. Be sure to exercise extreme caution when touching high side components as they can be very hot. Look for warm lines and components that are cold. Restrictions on the high side will have the same effect as an expansion valve or orifice tube, as they will cause a lower pressure after the restriction and cause cool or cold lines. If the touch and feel test seems normal, connect air conditioning manifold gauges or use the gauges on the refrigerant recovery machine to the low and high side ports and check the pressures. Low side pressures usually vary between 20 and 45 psi, and high side pressures are normally in the 120 to 210 psi range. R134A systems may run as high as 240 psi on the high side. If both the low side and high side pressures are low, suspect a low refrigerant charge, an obstruction in the suction line, a clogged orifice tube, or a thermal expansion valve that is stuck closed. If the low side is lower than normal and the high side is higher than normal, the airflow over the evaporator may be restricted. High low-side readings coupled with low high-side readings indicate an inoperative compressor or a compressor with internal damage. Higher than normal pressure on the high and low sides can be caused by a refrigerant overcharge, restricted airflow over the condenser, high engine coolant temperature, a thermal expansion valve that is stuck open, or refrigerant contaminated with air or moisture. On R12 systems equipped with a sight glass, air bubbles or foam in the sight glass indicate a low refrigerant charge. A few R134A systems use a sight glass, but the appearance of bubbles in an R134A system is normal. If system pressures are not within normal ranges, start your component inspection by checking for worn or loose drive belts and bent or misaligned pulleys. Check the radiator and condenser for blockages caused by mud, dirt, or debris. Look for evidence of oil on all fittings that would indicate a leak. And wiggle all electrical connections to make sure they're tight and making good contact. Start the engine and turn the air conditioner on. Look for the engagement of the compressor clutch. If the clutch doesn't engage or it slips, check for battery voltage at the connector when the AC is on. If battery voltage is not present, check the system protection devices and the wiring harness to determine the cause. If the clutch is not engaging or disengaging properly and makes a scraping noise, you may have to adjust the air gap by removing or changing a shim behind the pulley armature plate. If there's a knocking noise as the compressor is operating, the system may be overcharged. A slapping noise usually results from a loose drive belt or bent pulley. Faulty compressor clutch bearings will make a growling noise when the clutch is engaged and the bearing is loaded. Metal-to-metal knocking noises indicate internal compressor damage, and the compressor will have to be either rebuilt or replaced and the system flushed of contamination. A stethoscope or chassis ear can be used to isolate noises that may come from the generator or the power steering or brake assist pumps. The two common leak detectors are electronic leak detectors and fluorescent dye leak detectors. If you still have a torch-type leak detector, throw it away. Dangerous gases can be produced using torch-type detectors on R134A systems. To check for leaks with the electronic leak detector, set the sensitivity following the toolmaker's procedures. Then place the probe about 3/4 of an inch below the refrigerant lines, fittings, and components to be tested. Refrigerant is heavier than air, so leaks will show up under lines and components rather than above them. Move the probe slowly along the hoses and components, being careful not to touch the lines or fittings. A siren will sound when a leak is detected. Fluorescent dye detectors have come into wide use. Follow the tool manufacturer's instructions to inject the dye into the systems and allow the air conditioning system to run to circulate the dye. A black light is used to check for the presence of dye that is leaked out. Be careful when working with the dye and make sure none of it gets on painted surfaces, as it will stain the paint. Diagnosing HVAC electrical controls is the same as any electrical diagnosis. Start your diagnosis by reviewing schematics and wiring diagrams for the affected circuit. First, check to see which items in the circuit work and which ones don't. If the fuse is blown, use a circuit breaker in place of the fuse and begin disconnecting the connectors in the circuit in a logical manner until the circuit breaker no longer trips. The short will be in the segments following the last disconnected connector. Multimeters can be used to check for current. Voltage drop tests are useful to find excessive resistance that will cause diminished or no operation of components. The ohm meter function of the multimeter is used to check resistance of components. Always remove the fuse on circuits prior to using an ohm meter, or the meter may be damaged. Relays should be checked for current using a voltmeter and for continuity of the coil side and ground side using an ohm meter. You can check the input sensors and output signals on engine control units and body control units using a scan tool. The most common cause of failures in the air and vacuum control systems is leaking hoses and diaphragms. Hoses and connections can be checked for leaks by using a soapy solution on connections and looking for bubbles. A handheld vacuum pump can be used to check vacuum switches, actuators, and valves for leaking diaphragms. Some air blend doors use cables to control movement. Doors that do not fully open or close can be adjusted by adjusting the cables. Improperly adjusted doors will cause diminished performance in the heating or air conditioning systems. Lastly, vacuum reservoirs are used to maintain a supply of vacuum for use when the vacuum is operated under conditions that will develop low vacuum. One-way check valves maintain reservoir vacuum. A defective check valve will result in a bleed down of the vacuum reserve and no operation of the vacuum devices that draw on that reservoir. In this presentation, we've looked at the different types of air conditioning refrigerants and the procedures to recover, recharge, and recycle refrigerant on today's automotive air conditioning systems. We looked at troubleshooting and at some diagnostic tests you can use to confirm proper operation of the air conditioning system and its controls. If you're unsure of any of the areas that we've covered in this series, be sure to pick up one of the excellent textbooks to further study on heating and air conditioning systems.